Hello guys, welcome to Coding Journey. So today we are going to solve a question from CodeChef, pair pen. So the problem statement is given as such. We are given an array and we need to find such a pair I comma j such that it satisfies two conditions. The first condition is that I is less than j, where I and j are the indices of course, and this is in the bounds of course. The second condition is that the element at the ith position plus the element at the jth position should be greater than equal to element at the ith position multiplied by element at the jth position. So these two conditions we need to satisfy. Now let's say I'm considering ai as x and aj as y. So this will ultimately become this. Okay. So let's see some observations here. The first observation is that let's say that x is 1. So what are the all possible values we can get for y? Of course, we are assuming that this condition is satisfied. So let's see that for y is equal to 0. Does this get satisfied? It's 1 plus 0 greater than equal to 1 into 0. This does not satisfy. 1 greater than 0 doesn't satisfy. Let's see for y is equal to 1. 1 plus 1 greater than equal to 1 into 1. So 2 greater than equal to 1, yes, it satisfies. Let's see for y is equal to 2. 1 plus 2 greater than equal to 1 into 2. 3 greater than equal to 2, yes, it satisfies. So this means that if we keep on incrementing y from 1, it definitely satisfies when x is 1. So this is the first observation that we get, that when x is 1 and if y is anything greater than equal to 1, then the conditions are getting satisfied. Of course, we need to assume this condition. Okay, so let's get to the second observation. So we are given this condition basically. Okay, let's try to solve this condition. Let's say that x is fixed. So what we will have is x greater than equal to xy minus y, and let's just solve this. So what we'll have is this, ultimately we'll get this. So what does this mean? That when x is fixed, what we should have is, what y should be less than equal to x over x minus 1. Okay, so now if this is the given array and this is x, which is fixed by the way, so in here, in this portion, after this position, y should be basically less than equal to x over x minus 1. So we need to just find such elements which is less than equal to x over x minus 1 when we are at this position and the element is basically x. Okay, so one more thing we need to observe here is that y less than equal to x over x minus 1. So this term basically means what? If let's say x is 1, then this term will be y less than equal to 1 over 0, which is not defined. So this holds true for x greater than 1. Okay. Next thing is, let's check for x is equal to 2. So y less than equal to 2 over 1, which is 2. So for x is 2, we need y to be less than equal to 2. Okay, let's go further. When x is 3, y should be less than equal to 3 over 2, because it is x over x minus 1, which is nothing but less than equal to 1. Okay, so like after, when x is greater than equal to 3, what y should be is less than equal to 1. Well, this can be proved because let's say x is 5, so what we'll have is y less than equal to 5 by 4, and this term will be nothing but 1 point something, so ultimately it is less than equal to 1 only. So summing up all the observations, the first observation was, if x is 1, then y can be anything greater than equal to 1. Second observation, if for x, fixed x, y should be less than equal to x over x minus 1, and in that as well, if x is 2, well, y should be less than equal to 2, and for x greater than equal to 3, y should be less than equal to 1. Okay, so once we have these observations, let's try to take one example. So let's say this is an array given. This is the position we are at, and the value at that position is 1. So the answer for this position would be like all the elements, all the remaining elements after this position. So we will add all the remaining elements to our answer. Okay, so let's say if we are at this position and the value at this position is 3. So the observation 2 tells us that if x is greater than equal to 3, then all we need to do is find all those y which are less than equal to 1, which is nothing but 1 only. So what we need to do is, we just need to count the number of ones on this side. So for that we'll need to compute, like pre-compute the count of ones. So let's say the ones on this side are 2. So for this position, the count of ones will be 2. Okay, so the answer would be then, like, we'll add this 2 to our global answer, because 3 1 and 3 1 are the pairs that are getting satisfied. Okay, let's say that we are at this position and the element over there is 2. Okay, so when the x is 2, all we need to do is find all such y which are nothing but less than equal to 2. So let's say we have 2 over here. Okay, now what we need to do is, we just need to count the number of ones and the number of twos when we are at a position where the element is 2. So here the answer would be, for this position the answer would be 3. Let's say here it is 5. So here the number of twos here is 1 and the number of ones is 2 basically. So let's say this is the array of count of ones and the array of count of twos. Okay, so for this position the count of ones is 2 and the count of twos is 1. So this total will add it to our global answer, and that's the thing. So I hope you like the solution approach, and the code is been put in the description box. Please go ahead and look at it. Thank you.